Hello, lovely people. As usual, we're going to be waiting about 60 seconds, 90 seconds for people to show up, and then I'll get started properly. How is everybody? We took a nice week off from the web classes. Did everybody have a nice week? Has school been a bit stressful, or has it been all right? Let me know in the comments. My lovely colleague has just dropped the presentation into the comments, so download that if you'd like to fill it in as we go. Hello, Aisha. Hey, AFT. Yes, Aisha, the ideal gas law is PV equals nRT, and we will be getting to that in a bit. Sad, I'm sorry it's stressful. Yes, I can relate to being overloaded with work. But you guys get summers, right? Summers are nice. Okay, I'm gonna give it like 30 seconds. I'm glad you love the sessions, AFT. Oh, it's not really stressful. Oh my God, Sada, if I were in your position during my A-levels, I would have considered that pretty amazing. So I'm glad you're not stressed. Okay, all right, let's get started properly. I'm gonna, hello, Riley. I'm going to share the presentation with you now, if I can figure out how. Aisha, this is weekly, but this is the last of the really regular free web classes, which I will get to in a bit. Just bear with me. Okay, you guys should be seeing the presentation right about now, hopefully. Yes, I think you can see it. Lau, you have a test on this tomorrow. This means that this is very, very good timing. When do I do bonding? Because you don't understand bonding, Sada. There is a schedule on our website, which I will be showing you at the end of this. So, stay tuned. Okay, so I'm going to introduce myself, even though lots of you I recognize, and I'm sure you recognize me. So I'm Georgia. I'm the head of chemistry here at SnapRevise. I did a kind of master's in chemistry. It was like a combination between chemistry and some neuroscience as well. And I've been teaching for the last 6 years. So hopefully that means I can help you, get the grades that you would like. So lots of you already know this, but I'm going to go over it anyway. These web classes are not like everything you could possibly need to know about these subjects. It's supposed to be a recap. There's supposed to be key points. So like, you need to take care of the tiny details yourself. And we also will be looking at some exam technique, and there'll be time at the end for you guys to ask me questions. Funny videos 187, the web classes should be about an hour and 15 or something. Okay, and so this is the last week of weekly free web classes, because this is all in celebration of our beautiful launch of SnapRevise 2.0. So in our sort of ultimate package, the web classes come under that, and you can subscribe to that, and then you'll get lovely weekly web classes and weekly drop-in sessions. But I'm going to ramble about that at the end once we've learned stuff. So the nice thing is that somebody is going to be getting a free subscription to the ultimate package, which and that's with the whole 2 years of your A-levels. So I really would follow us on Insta and share a screenshot of the web class to your story and tag us in it, because then you get web classes for the next 2 years for free, which is always nice. And then everybody at the end of this will get a coupon code for SnapRevise 2.0 anyway. So even if you don't win the free web class, free subscription, you will still get a discount. Okay, so today we're going to be doing the ideal gas equation, as you guys may have seen. So the sort of objectives are to first understand, what it is, how it works, to rearrange the ideal gas equations to be able to use it for calculations, and to be able to rearrange the ideal gas equation to get the approximation for room temperature and pressure. So how we get there and how we use the approximation. And Malika, I am getting to the exam boards in just a second. Yes, and we won't be talking about how you measure how much gas you have. So we won't be sort of like looking at experimental data about the amount of gases. Okay, so spec points, we're going to be covering AQA, OCR, and edXL. I'm going to sort of just hang around on the spec point pages for like a few seconds. You can have a glance, but I'm not going to read them because that would be long. And I'm sure you guys have seen them before. And if you haven't seen them before, please check out your spec points for your exam board, because it's important that you actually know what you need to know. Don't just, let your teachers take responsibility for that. You guys have to do that yourselves. And last of all, we've got edXL. So take a look, because I'm going to move on in about 10 seconds. Okay, so the first thing we're going to do is talk about the stuff that we should already know that will make this web class, feasible. So please drop me your answers in the comments. The more you engage with this, the more you'll learn. So does somebody want to tell me what the definition of a mole is? What's sort of like the nice exam definition? So Sada says the amount relative to the mass of carbon-12. It is an amount, but it's not necessarily related to carbon-12. Does somebody else want to have a go? So Aisha says 6.02 times 10 to the 23. That's also involved. It's involved, but we need more. Ooh, Izzy's sort of closer. Jazel is also closer. So if we combine Izzy and Jazel's answers, we will have the answer. So a mole is, first of all, you have to say it's an amount of substance, right? So it's an amount of substance with Avogadro's number. And we should know that that's 6.022 times 10 to the 23 of particles. So any amount of substance, it could be atoms, it could be molecules. If you've got 6.022 times 10 to the 23 of those particles, that is a mole. Okay, so if that's a mole, what is molar mass? Drop it in the comments for me. So Trace says amount of substance that has the same particles in 12 atoms of carbon-12. So that's not quite. Sada says molar mass is the relative mass to carbon-12, weighted average, so no units. Aisha asked, is that the actual definition you would write in an exam? Yes, it is, Aisha. That is a good definition. It covers all of your bases. So molar mass is kind of, a lot of you are giving me the definition for relative mass. And molar mass, what we're doing is slightly different. And molar mass is also not molecular mass. So we're all kind of doing molecular mass. I'm going to give it to you. So it's the molar mass is the mass of 1 mole of an element. So you guys are right that it is relative to carbon-12, but that is the definition you would use for molecular mass and for relative atomic mass. So yes, so it's the mass of 1 mole of an element. Okay, and what is the formula for molar mass? What would we use? So this is kind of, those triangles you draw to help you do calculations. I'm looking for the triangle. Yeah, we've got some lovely people saying molar mass is equal to mass over moles. Yeah, so I'm going to draw you the triangle. So molar mass is represented with a capital M. So if you guys remember how the triangles work, if you want to know what molar mass is, you cover up molar mass, and then the triangle will tell you what calculation to do, which is mass divided by the number of moles. So I'm going to write that and your units, just so we have it. So the number of moles. Cool. All right. So that is everything we kind of need to know already. So I'm going to go ahead and move us on to the new stuff, or hopefully not new to you. Hopefully you covered a little bit of this in class first, but no worries if you haven't. Okay, so the ideal gas equation is basically the way that we can undertake molar calculations with a gaseous reaction rather than sort of something in solution. So that means that we need to take into account the volume of the gas and the pressure of the gas and the temperature of the gas. So I think some of the letters are obvious, but I'm going to let you guys tell me what everything is. So what in our PV equals nRT, what does the P mean? What does the V mean? What does the N mean? And the R and the T. So like when you're commenting it, make sure you like actually tell me which letter you're referring to, because lots of people just write in the answers and then I don't know what you're referring to. So yes, so thank you. Lots of people have said P is pressure, which is true. Can somebody, if anybody wants to put in units as well, that would be really helpful. So P is pressure, V is volume. Yeah, perfect. Anybody got N? Yep, N is the number of moles. Anybody said? Yes, Aisha says R is 8.13. And do we have anyone? So what, it is 8.13, but what is it? R is a constant. It is a constant. What kind of constant? Molar gas constant, says Lau. Yeah, so I call it the ideal gas constant, but molar gas constant is fine. So ideal gas constant, and as Aisha said correctly, it's 8.31. And then I'm not going to give you units because I'm going to ask you units in a minute. And nobody's, oh, right, yes. And Sada has said temperature is T, which is right. If you ever see a big T, it's temperature, little t is time. So big T is always temperature. Okay, cool. So Lau has rightly said our temperature is in Kelvin. So Kelvin is always the unit you're going to be using for science. Does anybody have, oh, lovely. Emma says meters cubed for volume. Perfect. Anybody for pressure? Ah, just as I say pressure, Serena tells me, right, cool. Yes, pressure is in pascals, which is PA, but I'll put pascals as well, just so that we are sure. Cool. What are we missing? So the only other one that we're missing is the ideal gas constant. What are our units for the ideal gas constant, people? Anybody? Yeah, so we've got lots of people saying something per mole. So we're not in kilojoules. Esther, that's close. And Lau is correct. We've got joules. Whoops. We've got joules per Kelvin per mole. Cool. So annoyingly, we have to go through sort of all the conversions that we could possibly be asked to do in our exams to be able to actually use the equation. Hello, Ward. It's nice to see you. So does anybody remember sort of like the approximation between atmospheres and pascals that you use for A level? So it doesn't have to be detailed. Yeah. So Natalie is right. Aisha and Sada is a little bit dodgy. I think you're thinking kilopascals, the two of you. So the approximation you use for A level is 101,000, so 101,000. But if you like Google it, you'll see that it's actually 101,325, and I don't want you to be confused if you do that. So it's just that A level uses an approximation rather than the actual number, but it should actually be 101,325. Cool, yes, and lots of people are converting to kilopascals, which is really, really nice. So Tracy, you sort of got it the wrong way around. You said 1 Pascal is 100,000 kilopascals. So remember, kilo means 1,000. So if you guys remember that, kilometers and kilopascals, and anything with kilograms is a lot easier to remember because kilo means 1,000. So there are 1,000 pascals in 1 kilopascal, which means that you have 0.001 kilopascals in a pascal. Oh, and Fazzy has sort of like jumped the gun and told me that the temperature in Kelvin is 273 plus the temperature in Celsius, which is completely correct. So 0 degrees is equal to 273 Kelvin. So if we can kind of like look at that and answer the question, a change in 1 degree Celsius, what does that sort of equal to in Kelvin? Yes, 1. Yeah. It's not minus 273. Actually, you might be thinking about absolute 0 rather than like 0 degrees Celsius, but that's sort of like advanced things. Wicked. So somebody's said centimeters cubed to meters cubed is 100,000, and you are totally right. So I'm going to write 1 times 10 to the power of 6 because 100,000 is not going to fit in my tiny, tiny space. But that leaves us just one thing in there, which is meters cubed to decimeters cubed, which is probably the most common conversion you're going to be doing, because if you guys recall, most of the solution stuff is in decimeters. But because pressure is kind of physicsy, we leave that in meters cubed to be nice and confusing to all of you. Yeah, it's 1,000. Thank you, Izzy. Perfect. Yeah, so we've got people saying 1 times 10 to the 3, which is also correct. However you want to say it, I just happen to be able to fit in the zeros this time, so I wrote 1,000. Okay, so if you can remember all of this, it makes things a lot easier, because that's the thing everybody loses marks for, right? Not having things in the right units, not converting things to the right units, because the equation is not that bad to actually use. Isn't 100,000 times 10 to the 5? Yes, Serena, thank you. I meant a million. Thank you. Cool. Right, let's have a look at room temperature and pressure. So a lot of the time, for a lot of the exam boards, you're never asked to use the ideal gas equation for any other pressure or temperature than room temperature, which in this case is 20 degrees. In a lot of other chemistry, it's 25 degrees, which makes things confusing. I know, I'm sorry. I didn't come up with it. So it's 20 degrees for the ideal gas equation is the standard for room temperature. And room pressure is, of course, 1 atmosphere, because we measure 1 atmosphere as the atmosphere on Earth. So we're going to sort of derive how we come up with an approximation for the ideal gas equation using room temperature and pressure, so that we don't have to use the proper equation every time. Does anybody have any ideas about what we're going to do? So I'm going to give you, because we've already looked at PV equals nRT. So what am I going to do with PV equals nRT, do you think, to find a good approximation? What is the moles? So yes, we do. We put the number in the equation, and we don't have moles yet, because what we're trying to do is figure out what we'll do if we just want to chuck in moles, rather than actually work out a real answer. So yes, so I'm going to shove in pressure, which we know should be in pascals. So our pressure will be 101,000. We have our volume, as in we don't have our volume, sorry. So I'm going to leave volume as V. We don't have our moles, as somebody nicely mentioned, so I'm going to leave in our N. We always have the ideal gas constant, which we have said is 8.31. So 8.31 is sufficient, but you will be given your gas constant in your data sheet, most likely. So you just use however many decimal places they use in the data sheet. And we have a temperature of 20, oh, sorry, not 20. See, I almost wrote the wrong units. We've got 293 Kelvin. Joules, so Vin says, doesn't R equals 8.31 for joules per Kelvin per mole? I'm not sure if it should be a 4. I feel like it should be a 4, and this is a typo. So like you could be right, but we're okay because we're just doing the approximation here. Okay, so right. So what I'm going to do is like literally just times out all of our values, right? So if we have, I'm going to rearrange everything so that it's just equal to V, because that makes things a little bit easier. So if I do that, I take over V and I have 1 times 8.31 times 293 divided by, whoops, 101,000. And what that gives me is 0.024 N. And so that is in meters cubed, right? So if that's in meters cubed, what might be useful to have it in? Because in lots of the questions, you're going to be given things in decimeters. So what might we want to do with the 0.24? Convert to dm cubed, yeah. So what do we get if we convert that to decimeters cubed from meters cubed? 24. Yeah, thank you, Jazel. Thank you, Sada. So, whoops. So in this case, if we're doing this approximation in decimeters cubed, we have an equation that says V equals 24 times N, which means that if you are asked a question about working out the number of moles or the volume for an ideal gas reaction, if it's a room temperature and pressure, you don't need to use PV equals nRT. You just need to remember V equals 24 times N. So just keep that in mind, because it's going to save you so much time in your exam instead of actually going through the whole process. Is everyone cool with that? Did that all make sense? Because we're going to go ahead and sort of use it now. So if somebody is a bit confused about how we got there, then I can sort of go back over that. But like, give me some emoji feedback. How are we doing? Yes, we're good. Yay. How do you watch the web classes on the Snap Revise app? So Isabel, because this one's on YouTube, it's the last sort of like regular free one. So we're doing it on YouTube so that it can be sort of like free for everyone. But once next week starts and the web classes start on the subscription, they'll be on the app. Yes, so everybody seems cool. So I'm going to go ahead and move on to an actual question using the approximation for room temperature and pressure. So our question says that magnesium carbonate and HCl react to make magnesium chloride, carbon dioxide and water. And it states that it's at room temperature and pressure. And as we know, because it's physicsy, we use 20 degrees / 293 Kelvin, and we use sorry, 1 atmosphere, which means we can use a lovely approximation that we just figured out how to apply. So the question is, work out the mass of hydrochloric acid required to produce 10 decimeters cubed. So Serena says, what happened to the moles from the last question? So the moles are in there. So did you see? So it says V equals 24N. So you don't like, so we were working out sort of like an equation that we could use for room temperature and pressure approximations. So N is our number of moles. Hi, Libby. Oh my God, I did it again. Hi, Libby. I'm sorry. My brain just cannot separate your first and last name for some reason. I'm going to call you Libby though, because that's your actual name. Okay. Javira says the web classes, so the web classes should stay on YouTube, as in the ones that already exist should stay on YouTube. Cool. So I'm going to get back. Thank you for being patient with my weird brain, Libby. Cool. So what I'm going to do is I'm going to remind us of our approximation. So the approximation we worked out for room temperature and pressure is the volume equals 24 times the number of moles, right? So we've been given the volume and we're looking for the number of moles, i.e., or well, we're looking for the mass, but the number of moles is going to come in there, right? Why do we have to convert the volume to dm cubed when it's meters cubed? So you don't have to, Zohar, but a lot of the questions you'll be asked in your exam will be in decimeters cubed. So it makes more sense to have the approximation in decimeters cubed. And if you happen to have a question in meters cubed, you can always convert it back, but almost all of them are in decimeters, which is why we've turned it to decimeters cubed. Cool. So I'm going to shove in my values. So to work out mass, we of course need the number of moles first, right? And then we can think about molar mass later on. But I'm going to go ahead and shove in the value of volume that we've been given. And because we've already converted to decimeters cubed, we don't have to think about the fact that the ideal gas equation is usually in meters cubed, because we sorted that out in the last slide. Cool. So what we're going to do is write the volume, which is 10. 10 equals 24 times the number of moles. And this should be trivial for you guys to work out the number of moles. So it's 10 divided by 24, because we've taken the 24 over to the other side, which gives you N. And we've got lots of people saying that the moles is 0.417, which is correct. So right now, all we know is that the number of moles of HCl, or not even, I'll get to that. The number of moles is 0.417, and I'm going to round to 2 decimal places just to to make things quicker, but remember your exam board always specifies the sort of automatic number of decimal places or significant figures that you should have. So you should always check what that should be. Okay, right. So we know that to work out, we know that the number of moles of CO2 is going to be 0.42. So remember that it's a gas we're looking at here. So we can't have already worked out the moles of hydrochloric acid, right? So we're working out the mass of hydrochloric acid required to produce 10 decimeters squared of gas. And gas is the operative word, so it must be CO2 that we're talking about. So we've got 0.42 moles of CO2. So how many moles do we need of HCl to get that number of moles of CO2? I'm getting lots of answers, and lots of them are right, but they're all from different parts of the question. So yes, thank you, Sada. So we need to multiply by 2, right? Because of the mole ratio. So if you look at the equation carefully, you can see that there's only sort of 1. If there's nothing in front of the CO2, that means we've got 1 mole compared to 2 moles of HCl. So we're going to times by 2 to get the number of moles of HCl. And that's going to give us 0.84. And then what we need to do, because we've been asked for mass, is what? So now we have the number of moles of HCl. How do we convert to mass? Lovely people. And I've already seen somebody do it up there, but if somebody wants to sort of like walk me through what exactly it is you did. Yes, so Sada says mole times molar mass. Yes, so I'm going to give you the molar mass of hydrogen, which is 1. And I'm going to give you the molar mass of chlorine, which is 35.5. So yes, and Sada's already said it for me. So that means that the molar mass of HCl is 36.5. And so I'm going to sort of draw us our little triangle, because I want you guys to get in the habit of drawing the little triangle for every question that it involves, so you never get the equation wrong. So we should be doing, we're looking for mass, and we've got molar mass and number of moles. So we're going to be doing 36.5 times 0.84, which gives us, and lots of people have got a lovely answer. So Sada says the answer is 30.416 recurring. And yeah, and so does Izzy. And we've got some different, we've got a few differences in sort of like the exact number. And I wonder if some of you have put a different number of decimal places for your number of moles. If you do it with 0.42, you do get 30.66. So I'm wondering if you do it with 0.416, you get 30.441. But nevertheless, we all have reasonably accurate answers, which I'm happy with. Okay, wicked. So we should have 30.66 grams. And if you were doing it to 3 significant figures, which I think some of you have, you want to make sure that it's 30.7, not 30.6, because of course you have to round up. But yes, so that all seemed to go actually quite well, didn't it? Okay, so tell me, how are you guys feeling? How is that all feeling? Is it feeling okay? Can we go ahead and do an exam question? Libby says yay, or a smiley face. Zara says straightforward. Sohal says great. Riley is happy. Okay, everybody seems happy. Sabrinolad says 2. Okay, so if there is a problem in there, what I want you to do is tell me what slide was confusing or what bit you're confused about, because I cannot help if you don't tell me what's wrong. Does the Sample Revise cover the Pearson Edexcel International? Okay, no worries, Isabel. So we tend not to cover specifically the international A-levels, but most of the international syllabuses are very similar. So I would suggest you do is you can watch the web classes and things like that, but make sure you keep an eye on your own specification, just in case you see something, you're like, oh my God, I haven't learned that. Do I need that? Check in your own specification. And that's the same for all of you. even though I, make sure I put the specs at the beginning and cover material that is on all of them, you should always be making sure that you know what you need to know. So Zohar has persuaded the school to cover the expenses for Snap Revise. Oh my God, I'm so excited for you. That's really cool. I like that your school has done that. Okay, we are going to move on then and go ahead and do a couple of exam questions. Cool. So this exam question says, a student heats 5.29 grams of nitrate, some kind of nitrate, and collects the gas at room temperature and pressure. So that's RTP is the acronym for room temperature and pressure, as seems like self-explanatory. Cool. So we've got, we need to calculate the volume of gas in decimeters cubed obtained by the student, and we've been given the molar mass, which is good. Okay. So what do we want to do first? What do we need to do before we do anything else? Find moles. Yes. Yeah, we need to find the number of moles of SR NO3 2. So how are we going to find the number of moles? So I'm going to give us our little triangle, and please try to memorize the triangle. It is so helpful. It will pull you through most of your calculations questions. Do you need to learn what standard RTP and pressure is? It depends on your exam board whether you need to remember that it's RTP or not, but it will always say standard temperature and pressure next to it anyway, so it doesn't matter. Cool. Yeah, lots of people saying. So we've got the mass here. We've been given the mass, which is 5.29. And we've been given the molar mass. So it's nice we don't even have to check our periodic table. So it's 211.6, and we're going to be doing it to the number of decimal places they give us. And that should give us 0.025 moles. Lovely. And lots of people have already said that. Perfect. And Domsky, perfect. Isabel, perfect. Billy. Okay. So we know the mass, the number of moles of this SrNO3 2, but because it's the ideal gas, we need to be looking at gases, right? So how are we going to work out the moles of gas? Multiply by 24. There's something we have to do before we multiply by 24. Molar ratio, yeah, we need to think about the molar ratio. So in this case, we've got 2 moles of this SrNO3 2, and we've got 2 gases. We've got NO2 and we've got O2. So technically in total, we have 5 moles of gas compared to 2 moles of the reactant, right? Which means that we're going to have to do what to 0.25? So we don't want to multiply by 2. If we multiply by 2, that would give us 4 moles of gas, not 5. What do we need to times by? We can't just times by 5 because that would give us 10 moles of gas. So Sada says, I don't get it. So I'm going to quickly run through what just happened. So we've been given, we know that the student heated this mass, this 5.29 grams of the reactant, which is a solid, right? We can't use the ideal gas equation to work out the volume of gas of a solid, because a solid is a solid, right? So what we need to do first is figure out the number of moles of the thing we know about, which is the solid. And now that we've got the number of moles, we need to work out the number of moles of gas produced by that. So we know that 0.025 moles reacted because we did our mass divided by our molar mass from this triangle. And now we have, now we need to use our molar ratio to figure out how many moles of gas were produced. So we've got 5 moles of gas in total produced compared to 2 moles of the SrNO3 2, which is the solid. And we know that it's 5 because we've got 4 of NO2 and 1 of O2. Yeah, so lots of people are saying that we need to multiply by 2.5, which is exactly what we need to do. So the way I like to put it is I like to say 0.25 divided by 2, because that sort of gets us to a 1 molar ratio, and then times by 5, which gets us to the number of moles of gas. But that is, of course, the same as timesing by 2.5 or timesing by 5/2, right? Yes, yes, you can, Sada. That's exactly what I was about to say, or have just said. Cool, perfect. So the answer you get for that is 0.0625, which is what Andomsky just said as well. Okay, so now we actually know our number of moles of gas produced. We can shove that into the ideal gas equation approximation. We don't need to use PV equals nRT because we've been given the fact that we've got room temperature and pressure, and we just worked out like a really awesome approximation. Timesing is not English. Ali, English is a forever evolving language. And each generation, the generation thinks that the new generation has made up words, and then those words become normal English, and then the next. So I'm going to use timesing. If this was grammar, you know, we would have a problem, but it's not. Cool. So we know our approximation is volume times 24 times the number of moles. Why did I divide by 2? Sabrina lad, I divided by 2 because we have 2 moles of SrNO32 in the equation compared to 5 moles of gas, right? So 1, 2, 3, 4 for NO2, 1 for O2, which makes 5 moles of gas, which means to work out the number of moles of gas reacted in the sample, we need to divide by 2 because there were 2 moles of SrNO32, and then to get to sort of like 1 mole, and then we times by 5 to get to 5 moles. We could have also just times by 2.5. Either is fine. Cool. So I'm going to do volume times 20 equals 24 times m. So volume equals 24 times 0.0625, which gives us 1.5 decimeters cubed, and our answer has asked for it in decimeters cubed, so we don't need to think about meters cubed, centimeters cubed. So the answer is 1.5. Zohar, yes, you can use V equals 24 and when it's standard room temperature and pressure. If it's not, I'm afraid you're going to have to use PV equals nRT. But you'll find in most of the exams, apart from Edexcel likes to sort of throw you in at the deep end and use the proper one, but lots of them are room temperature and pressure. Why do we multiply by 5? Because there are 5 moles of gas. You can see that here because we've got, so both the gases in the equation are NO2 and O2. And we know they're gases because they've got the little G after the state symbol that means gas. And there's 4 moles of NO2 and there's 1 mole of oxygen, because of course, if there's no number in front of the O2, that means that there's 1 mole. So 4 plus 1 is 5. So we've got 5 moles of gas being produced per 2 moles of SrNO32. What formula did I use? Why does V equals 24? It doesn't equal 24, it equals 24 times the number of moles. And it equals that because, do you remember the derivation we did over here? So this, when we shoved in, we used PVNRT and we shoved in our value for room temperature, which is 293 Kelvin in physics, and pressure, room pressure, which is 101,000 pascals. So we calculated sort of an approximate formula for the ideal gas equation using the values for room temperature and pressure, so that in your exam, you don't have to keep using the ideal gas equation, you can just use the approximation. So is this relevant for all gas questions? No, only the ones that are at room temperature and pressure. If they're not at room temperature and pressure, you must use the full ideal gas equation. If they are at room temperature and pressure, you may use V equals 24 times m, and that's for decimeters cubed, not meters cubed. If it's meters cubed, you need to divide by 1,000. Yay, okay, we're getting it, cool. Everyone happy for me to move on to the next exam question? Give me a show of emojis. You did it in GCSE. That's really interesting. Lots of people don't do this in GCSE at all. Oh, the V equals 24n. That's interesting. Okay, seem to be happy going forward. So I'm gonna go ahead and and go forward. Cool. So the first part of the question says, when heated, iron 3 nitrate, which has a molecular mass of 241.8, is converted into iron 3 oxide, nitrogen dioxide, and oxygen, and then very kindly gives us the nice balanced equation on the other side. And it says a 2.16 sample of iron 3 nitrate was completely converted into the product shown. Calculate the amount in moles of iron 3 nitrate in a 2.16 gram sample. So this is AQA, EdXL, and OCR. I thought you divide from 1,000 to go from cm cubed to dm cubed. Yep, and you also divide by 1,000 to go from dm cubed to meters cubed. It's both. Cool. So someone help me out. If we've got a 2.16 gram sample of iron 3 nitrate, and we know that iron 3 nitrate has a molecular mass of 241.8. What are we going to do to work out the number of moles in the sample? Yes, thank you, Libby. So we've got our triangle thing again. And if this triangle thing is not in your head yet, it really, really should be, because you're it's going to be tricky if you don't have it in there. Cool. So, oops, I have written ends in 2 places. That's not helpful, is it? Right. So we should be doing mass, and we've been given the mass of 2.16. And it's going to be divided by the molar mass, which is 241.8. And note that I'm writing all of my working because you want all of your marks, of course. And the answer you should get if you shove that in your calculator is 8.93 times 10 to the minus 3. And always write your units. And in this case, it's moles. Okay, and Light Hope. My God, what an inspiring name, Light Hope. Yes, you're right, kind of. Yes, you are right. So the next question says, calculate the amount in moles of oxygen gas produced in this reaction. And if you'll notice, the exam questions break down the whole thing, so you don't have to like work it all out in one go for this question, which is kind of nice. Cool. So we're going to try and work out the number of moles of O2. So you're right. So what we've got here is, again, we need to look at our molar ratios, and lots of you are saying how. So I'm going to go ahead and sort of explain your wonderful answers because they are correct. We've got the number of moles of iron 3 nitrate, right? Which is here. And we know that iron 3 nitrate is 4. We've got 4 moles of iron 3 nitrate reacts to create 3 moles of oxygen. So what we're going to do is divide by 4 to get us down to 1 mole. So if we do 8.93 divided by 4, times 10 to the minus 3, that would get us down to what 1 mole reacts to. And then because we need 3 moles, not 1 mole, we'll also times by 3. And you guys could have done this by just timesing by 3/4, or you can do it in steps. You can do divided by 4, then times by 3. And that should give you 6.70 times 10 to the minus 3. And notice that I've left it in 3 significant figures. Even though it doesn't say in the second part, give your answer to 3 significant figures. If the question mentions that at some point, just keep it in 3 significant figures. You don't want to lose marks for not putting that in. So lots of you had lovely, correct answers. Jaisal, yours has gone slightly dodgy. See, put that in your calculator again and see if you can see if it comes up with the right answer. Okay, so we're going to do the next sort of chunky bit, and we've been told that the volume of nitrogen dioxide gas is what we want. We want to figure out the volume, and we want it at 293 degrees Celsius and 100 kilopascals. And as you might have noticed, 293 degrees Celsius is not room temperature. So some people might have been a little bit tricked by the fact that 293 Kelvin is room temperature, which is kind of mean. But if you look really carefully, it's Celsius. So we cannot use our approximation we've got to use the full ideal gas equation. So I want you guys all to shove in the ideal gas equation to the comments, because you should all know it by now. So please shove it in there so that I know that you know what the ideal gas equation is. Thank you, Jaisal. PV equals nRT. Thank you, Libby. Thank you, Ramin. Yeah. So I know that we're just sort of typing it in the comments, but do make sure that when you write it in your exam, you do the right things in capital letters and the right things in lowercase, because they mean different things in different cases. So we've got, whoops. So we know we need to work out PV and RT, and we're looking for the volume. And so I'm just going to go ahead and shove in, not shove in, I'm going to try and figure out the pressure first. So if you'll notice, the pressure is in kilopascals and the standard units are pascals. So what is 100 kilopascals in pascals, people? And please note how carefully I go through each question looking for units, because most people can shove in information to an equation, right? That's not what they're testing you on. Well, to some extent, they're testing you on your ability to think about your units and to think about converting to the right units, because that is always what people forget to do. So yeah, we've got lots of people saying, is that right? Yeah, 100,000 pascals. Sorry, it takes a little while to count all of your zeros. Yeah, so what we want for pressure is 100,000 pascals. Is there anything else that we need to change the unit of? Guys, what else is not in standard units in this question? Temperature, yeah. So temperature we've got in Celsius. So what do we need to do? Add 273. Thank you, Light Hope. So we're going to be doing 293 plus 273, which is 566 Kelvin. Cool. So everything, we don't have to think about units for anything else, because the ideal gas constant has been given. So that's in standard units. So that's all we need to do. So we're trying to work out the volume of nitrogen dioxide, which means that when we're looking for our N, the number of moles, that must be for nitrogen dioxide, right? So if we know, so we've got N equals NO2, and we know the number of moles of iron 3 nitrate, we know the number of moles of oxygen. So what are we going to be doing with the number of moles? How are we going to work out? So if there's 12 moles of NO2, what do we do? So Izzy says 8.93 times 10 to the minus 3 times 3. And that is completely right. So 8.93 times 10 to the minus 3 times 3. You could have also done 6.70 times 10 to the 3 times 4, because that's the oxygen one, and 3 times 4 is 12. But this, either way, is fine. So the number of moles of NO2 is 0.0268. And at this point, we have all of our information to be able to use PV equals nRT, because we've got N, we've got T, we've got P, and we've been given R already. So we're looking for V. So all I'm going to do is move the P over to the other side so that our equation is V equals nRT over P, because where did I get the mass? How did I get the mass of NO2? So it's not the mass, remember, Serena, it's the number of moles. And what I did is looked at molar ratio. So here we can see that NO2, there's 12 moles for every 3 moles of oxygen that's produced. And we've just, or actually we're looking at iron nitrate for the way I did it. So we've got, we've got 12 moles of NO2 for every 4 moles of iron 3 nitrate that reacts. So to get from 4 to 12, we times by 3, right? Because 4 times 3 is 12. So we know that there are 8.93 times 10 to the minus 3 moles of iron 3 nitrate reacting, because we worked that out in number 3AI. So what we do is we times that by 3 to get 12 moles. Cool. So now all I'm going to do is shove all of that information into the equation. So we've got the volume times n, which is the number of moles, 0.0268 times the ideal gas constant, which has been given as 8.31, times the temperature in Kelvin, which is 566, divided by the pressure in pascals, which is 100,000. And that should give us 9.06 times 10 to the minus 4 meters cubed. And keep in mind the meters, right? Because we did not use our approximation. We did not convert volume into decimeters cubed. So pretty please, if you're not using the approximation, you're in meters cubed, because physics really likes to use meters cubed. And it asks for it in meters cubed also, so you don't need to do anything. Okay, Sada, what didn't you get? So Sada got 1.26 times 10 to the 3. How do I get 9 is that not what you guys are coming out with? I'm going to shove this into my phone calculator just in case it's somehow a typo, but it really shouldn't be. Okay, so we've got 0.068 times 8.13 times 566 divided by 100,000 equals 0.126 times 503. No, you guys are right. This is also what my phone says. So I'm going to assume that this is a typo. That is exactly what it is. If it's not a typo, then I will like print a correction on our website. Then for now, I'm going to assume it's a typo. It's the moles calculated. Maybe the answer is for 0. Oh, it is. Okay. You guys are perfect. See, this is why it's so important to read the question properly. Yeah, you're totally right. So we did not need to use the number of moles in the previous question. We needed to use the number of moles in the actual question. So when we times 8.93 times 10 to the 3, we should have been timesing 0.00642 by 3. And that would have given us, and give me a second, because I actually have to put this in my calculator, 0.00642 times 3, which is, 0.01926. So I'm going to shove that in here instead, and we will see if we get the right answer this time. So 0.1926 times 8.13 times 566 divided by 100,000 does give us the right answer. Yeah, perfect. So both answers are correct. If the first way we did it was looking for the number of moles in the sample that they mentioned in the first part of the question, then we would have been right, but we were not. So if I had done that question in my exam, I would have lost both my accuracy mark and one of my method marks. So be careful, be super careful, because reading the question is so important, and even your teachers don't manage to do it properly. Okay, so that is the end of all of the sort of like teaching parts. We should be good with performing calculations for moles and concentration and volume. We should know sort of what the ideal gas equation means, and we should be able to calculate with the room temperature and pressure approximation, and we should be able to calculate using the actual equation as well. And yes, I was on time this time, Sada. I'm so proud of myself. Yes, I have problems with timekeeping. So now I'm going to spend the last 7 minutes introducing you to like all of the stuff. So SnapRevise 2.0 is like finally here, which we're all really excited about and a bit stressed about, because getting things to launch is always, tricky. But yes, it's very exciting. Oh, thank you, Zoha. Everybody's proud of me for timekeeping, basic life skill. And my students are proud of me. I will tell my mum. She'll be very proud of me too. Can I do balancing redox reactions? Yes, I can. That is coming up in the future, but as most of the web classes will be now, it's all a part of Snap Revise 2.0. So I know you guys have been asking about pricing for a really long time. So this is the pricing. So for the basic package, it's £10 a month, unless you already sort of signed up, and then it will be cheaper for you. So this is why I kept saying, please sign up before the launch, because things are cheaper for the people that were already signed up. Jazel, yes. So I will get onto the ultimate in a second. Pro is 30 quid a month. Ultimate is 50 quid a month. So I'm going to do a little bit of an explanation, because I know that sounds like a lot of money, but what we're trying to do is replace needing a tutor, right? Because you guys can ask me questions. We're going to be doing 2 web classes for chemistry a week and 2 drop-in sessions where you can like literally ask me anything about the subject, right? So if you were to hire a tutor, which is like £30 an hour, that's like 2 to 4 hours a week of a tutor would be, for £30 an hour, would be £120 a week. So that's what we're trying to do. We're trying to make tutoring cheaper. And I know that like compared to watching a YouTube video that is free, it is more expensive, but compared to actually being able to ask people questions, if you were to hire a person at home, it would be a lot more expensive. That is all I can say. I hope that it is worth it. And I know that Logan, you're saying that you can't afford that all. Do the competition on Insta, because somebody is going to get an ultimate package for the next 2 years for free. So if you take a screenshot, if you haven't already done it, if you take a screenshot of the web class and you put it on your Insta story and you tag us in it, please remember to tag us in it. And if your Insta is on private, then you have to like drop us a message to say that you've done it and send a screenshot of that, because otherwise we won't actually see it if we don't already follow you. So, you know, like I know some people won't be able to afford that, and we'll keep in mind that we're going to be doing a few free web classes on a Sunday, like probably about like 1 a week for each subject. But yes, I know that it's expensive for some people, but it's a lot cheaper than hiring an actual tutor, and we did our best to keep the costs down, but you know, it does cost money to make. Do you have a free trial? So yes, there is a free trial, but the free trial is for the basic and the pro package, not the ultimate package. Yes, and Zoha makes a really good point. So Zoha has mentioned that their school was convinced to pay for this for their students. If you want to go ask your teachers, go ask your department heads to try and do that for all of the students, then like go ahead, and then that takes it out of your hands. Can I ask how much it is if you've already subscribed? I don't have the numbers right in front of me, Libby, but if you go on the website and you're logged in, it will tell you how much it is. And I'm going to sort of like do a really quick run through of that now. So setting a reminder, we've got our A2 class or our year 13 class on tomorrow. So what I'm going to do now is show you guys the actual website. The next topic, so tomorrow's topic is the Chatelier, and I'm going to be showing you the schedule in just a second. Just give me 1 sec to get to share the actual thingy with you. I'm going to share. You're welcome, Ali. Okay, so what I'm going to, can you guys see that? Is there, so guys, as for discounts, I'm not actually that sure, but if you like go on the website and put everything in the baskets on the website, it should apply discounts automatically, but I have not learned yet all of the discounts for multiple subjects and things like that. Okay, so I'm waiting for the computer to load things because internet is being slow. So Zoha, there will be some more free ones on Sundays, probably one a week, but not sort of like as often as it would be for the paid one. Okay, so I'm gonna, so anyone that is like really, really priced out, please, you know, go ahead and enter the competition on Insta. So I'm gonna really quickly show you around because I think it's really cool. And I want to sort of end on like a happy note. So I'm just going to walk you through the sign up process. So I can show you what actually happens. I'm going to pretend to be a student. And I'm going to call myself, I don't know, something like Peanut Hat, but actually use my email address because otherwise it won't work. SnapRevise. So the Insta competition is for SnapRevise 2.0, the ultimate package. So the one that comes with everything, including the web classes and the drop-ins and the ability to sort of like message me at any time of day and ask me questions. So it's a lot. You're basically getting like a tutor that's always there. And I'm going to make up a password and it's going to be Peanut Hat again because, you know, and I go to the School of Peanuts. And I am in year 12 because that makes sense. Cool. So you do things like click on chemistry and then you pick your exam board, or you might pick another subject. So let's say you're doing biology, but for EdXLB, you'd also pick that. And then you decide what you want. So if you're being like really ambitious, you pick A star for both of them. And then you like just say why you want to be doing it. So I'm worried I'm going to fail is what I'm going to pick. And then, so what I'm going to do is just show you what happens on the trial. So I'm going to click go to trial. And it's really cool. So like if, for example, we wanted to learn about fundamental particles, you start with like a diagnostic quiz. So you sort of like answer questions. So like which one is Rutherford's atom? And I'm going to pick something random. So it's not B, but that's fine. So I would have gotten B wrong and it would tell me, it's later on going to tell me what I need to know because of the diagnostic quiz and sort of like what is the model of the atom that we use, and we currently use none of those models. Oh, okay, so I didn't know that either. So it's Bohr's model. How many electrons does it have? Oh, okay, so I'm going to say 9 and so I knew something. I knew the number of electrons. So what we're going to do is press get started. And what happens is, so the things that you do know don't come up, and the things that you don't know sort of like pop up on the things that you need to do. So you can watch a video and then you can answer the quiz to check if you know stuff, to check if you've understood the video. And then once you've done that, you can go on and look for an exam question. So the exam questions will do a run through of one of the exams rather than you doing them yourself. And then later on, if you can go and find, so these are all exam questions that don't exist on the internet already. We've come up with them ourselves, but they should match your exam board perfectly. And you can we'll be constantly adding more of them, so you can't run out. And I know with the new 2015 specifications, people have been running out. So just to let you know, sort of these exam question bits, they belong to the pro feature. So even if you can't afford the ultimate feature, you can still get lots and lots of exam questions, which is really useful. We will also, there's also nice revision guides. So like they're pretty and it means you don't have to take notes in class, although you should still take notes. But they're nice, pretty concise notes specifically for your exam board, which is really lovely. And then if I like go back to there. So we can look at the web class space. So here, if you click on web classes, what you can see is the schedule. So this is the schedule coming up for the future, guys. We have coming up on the 29th, so that's next Tuesday. For year 12, that's going to be electronic configuration. And for year 13, it's weak acids and bases. But remember, there's another year 13 one tomorrow on the Chatelier's principle. So that's this is the schedule. So even if you just sign up to the free trial, you can still see the schedule and see what's going to be happening for that. And not only do we have like these web classes, we also have drop-in sessions. So after the web classes, what we'll have is I will literally just be sitting here. And like, if you have like a homework question that you're really stuck on and you need help with, or just like you want to ask me questions about exam technique or like anything, I will be here for an hour and you can ask me anything. And there's also a feature that on any of our videos, you can comment and ask me a question if you're confused about something, and I will get back to you within a day or so. So like, there's so much. And I really, like, we've worked so hard to like bring this about, and I'm like super excited about it. Look, guys, I even filmed a really embarrassing video for the website, and that stuff's really hard to do without feeling very silly. So yeah, so like, do sign up if you can afford it. If you can't afford it, you've got two options. You ask for somebody else to pay for you, you ask your school to pay for you, or worst comes to worst, you go ahead and sort of sign up for our Insta competition to try and get it free that way. But I hope that you guys think that it's worth it, because, you know, I worked super hard to make this, like we worked really hard to try and just think of everything you guys would need to do well in your A-levels. So I'm going to go ahead and go back to our presentation so that you guys can have the discount code, because I did say that, that there would be a discount code. So anyone that wants to sign up and wants a discount, there's sort of like 10% off for the first month, just for everyone. So everybody can have £10 off for the first month. So I'm going to go ahead. Oh, did I stop this? I paused the screen share. Okay. So here is a sort of code for £10 off. And remember that you can sort of cancel your subscription. So if you can't afford to do it the whole time, but you can afford to do it some of the time, that's also an option. So yes. Okay, so before I go, any questions, people? You've been so great. So you guys have been really focused today. I really, really appreciated it. The winner's going to be announced tomorrow on our Instagram. So just please remember, if your Instagram is on private, you have to send us a message and show that you did put it in your Insta story, or we won't see it. That's happened to some people before. You're welcome, Libby. So the winner of the competition will be announced tomorrow, folks. You're welcome, Logan. Can I tell you a useful website for chemistry? Yes, SnapRevise is a useful website for chemistry. And there's some free content on there as well. And there's also the cheaper subscriptions that has lots of good content also. Would we get any other sorts of questions other than these calculations for ideal gas? Not really. You might be asked, so usually it's just approximation questions, so approximations for room temperature and pressure, and then sort of like actually using it. You might get questions sort of like that are cross topic. So you might have to balance your own equation. You might have to talk about the Chatelier's principle by the time you sort of have covered that. But it tends to be nothing else specifically in this topic. It just sort of combines with other topics, like how we had to use the molar mass equation within. Okay, if nobody else has other questions, then I'm gonna head off and, you know, go home because it's really late. How do you apply for the competition again? So what you want to do is screenshot the web class, and then you want to put it in your Instagram story and tag us in it. And you have to tag us in it or we won't see it. So that's at SnapRevise. And if your Instagram is on private, you have to send us a private message showing that you've screenshotted the web class in your story, or we won't have seen it. And we won't know that you did that. So you won't be entered. So please, please, please do that if your Instagram is on private. Okay, I'm gonna go. Thank you guys. Thank you everyone. I hope to see you, if you're in year 13 and revising, I will see you tomorrow for another free one. And there will be other free ones on Sundays every now and again, so don't worry. But yes, I will see you lovely, lovely people. How many more web classes are left? For the weekly free ones, this is the last free weekly one. They'll be sort of more sporadic on a Sunday free on YouTube. And then there will be every week, one for year 13, one for year 12, and then one drop-in session for year 12, one drop-in session for year 13 every week as well on the actual website. Cool. I'm gonna go. Bye, lovely people.